Perfect. So, hello everyone. Nice to be here. Nice to meet you in person and online. I'm really excited to be here. It was my first trip, like long trip after COVID. And yeah, it took like 12 hours to reach here, but finally I'm here. So, I'm Salih. I am a developer advocate from AWS Amplify team. And today I'm not going to talk about Amplify. Today I'm going to talk about Flutter and how it works. And just a disclaimer, this is going to be a quite technical talk. We will see a lot of architecture decisions, why such decisions has been made and so on. So it is possible that you might drift away along the way. It's completely fine and understandable. So in the Chicago report, I think this is the only Flutter talk, and this shows that Flutter is still brand new comparing to other technologies because it started in 2018 and it became stable in 2018, but actually that's not the whole story. Flutter itself started as a fun project from a couple of folks from the Chrome team actually, and they just ripped up everything out of the V8 engine, and they said, okay, let's try to render some views, render some images, and see how it goes. And back then, it was even used in JavaScript to do all of these operations. And as they did run some benchmarks and so on, they realized that actually it was doing a great job, and they could actually turn this into an engine to provide some overview or provide some better experience with the graphics rendering. So they said, okay, let's continue, let's go with this. Around 2015, they said, let's have a language that we can control the features and everything from. Plus, they were also aiming for a language that was not so different than what they had before. So they said, okay, let's continue with Dart, because Dart was a web project that was supposed to kill JavaScript, and it turned into a rotten project for a while. But luckily, thanks to the Flutter, it turned back to life. And in 2018, 4th of December, we had the initial version of Flutter, which was 1.0. And with that version, they gave the ultimate promise of Flutter. They said, you can write the code once, and you are able to deploy it to any target that you have in your mind. So first targets were iOS and Android. And as time moved forward, they wanted to actually improve their promise and go for even a more deeper research, and they said, okay, Dart is a web language, and we already have systems to move forward to actually run web out of the box. So in 2021, with the Flutter 2.0, they said, okay, now we have web as stable as well. And lastly, this year at Google I/O, now they decided to have a desktop support as well along the way, and now it is on the stable. Disclaimer, my understanding with stable is different than theirs. So I would say good beta, but not stable. But I take their word. I think you can do some apps, but I don't know if you've been to Google I/O this year, but I worked on the Superlist app that did this, that has been done with this Flutter framework, and we did so many great stuff for sure. And Flutter helped us a lot to keep a decent code base, but still. And there were challenges, so that's why I would consider it more like a beta than stable. But anyway, so if you heard of Flutter, probably you heard something called widgets. Widget is the building block of Flutter ecosystem. You would have either a stateless or stateful widget most of the time to take care of your needs. Stateless is basically doing what it says. It's stateless. It doesn't hold any changeable operation in it. You just show the information that you pass in. And stateful widget is the widget that is helping us to actually keep a reference to an object called state to make it mutable, because you will see in a couple of slides that Flutter's ecosystem has made several decisions in a way to make your life easier, and one of them is making these building blocks immutable. So they're highly disposable. You can just use it and throw it away, and you will not have any performance impact thanks to Dart's, the garbage collection ecosystem, and the architecture of Flutter that you're going to be learning. If you want to create a widget, actually, it is quite straightforward. Like in most of the object-oriented languages, you just create a class, and with the stateful widget, as mentioned, you need to create a state object to keep the state, the changeable information. And this state class is a special class. It keeps some information in it, and you can actually alter this and make it available on the screen. For example, you can have a list of like endless elements, and you can see that with the tab you can toggle something, and according to an information you can just say change the icon or not. You can also see here that it is using a heavily composable style that you can gather your UI from. I mean, there has been several compose, like Jetpack Compose related talks already, and probably you heard about Swift UI as well. Like this is an actual, let's say, de facto way to go right now. Like it is helping you to write your code in an understandable manner and with the language that you use for your application as well. In this case, it's Dart. In the Jetpack Compose, it's Kotlin, and so on and so forth. So for changing the state, you need to use a special function called setState. The setState, actually, if you have done any bit of React, this function shares the same name out of the React's direct function as well. Like in React, it's setState. It's also the same here as well. Why is it like this? Because when they were actually architecting Flutter, they got heavily inspired by how React is rendering widgets and how React is actually acting upon its UI components. And that is why even some namings are more or less the same. So earlier I said like everything is a widget, everything is a widget. You will have stateless widget and stateful widget. But I also said there are a lot of architectural decisions behind the scenes that is helping you to have these immutable operations to work flawlessly and change any UI component that you have in your application. So I will contradict myself now and say, actually, everything is not a widget. Because Flutter has an architecture that would help you to actually write the code as a widget, but behind the scenes, it will have a lot of helper components. Let's see those components and see how it is actually keeping the underlying state and how it works in the basic manner first. Then we will carry on with the more complex part. So first part is creation phase. Like as I said, you just write a widget. You saw that there was stateless widgets, there was icon, there was text, and so on. So these are like your simple building blocks. But actually behind the scenes, it creates something called element. Widgets are immutable and they are disposable, I said, but elements are not like that. Elements are the representations of the widgets, and they keep the information about their parent, and also they keep a communication between widget and the render object. The render object is the object that is using all the information that is provided to it to draw some UI. So you can see that actually widgets and everything is disposable, but element and render object is not. And how it works, it's again quite straightforward. For example, you can have a column, which is a widget that holds several children. I think in Jetpack Compose there's lazy column to do the list operations with scrollable manner. I'm not so sure. And it will create an element, something called multi-child render object element, which will be created in render flex. So it will create a render object to draw several child elements on the screen, and this operation will be orchestrated by the element, which is now multi-child render object element. So you created everything all right, but how about updating mechanism, how it works? So imagine that you have text, and it will have the multi-child render object element as well. It will have a render paragraph as the render object. And imagine that you have a button to change the text. And this button also has a direct element as well. And one thing to keep in mind here is that each widget should have an element to do its heavy work. But each widget doesn't have to have a render object, because you don't have to draw something on the screen all the time. You can, for example, define the child widget like padding. You can say that, okay, put a padding of 8. At the end of the day, what is drawn is the child that is keeping the information, and that information is passed by the element, because as I said, the element knows the parent and its information direct to it. So, how the updating works. Like in the widget we called setState earlier, it will actually call something called mark needs rebuild. So it will tell element that, okay, it needs to get rebuilt. And element will say, okay, now I'm scheduling this widget to be rebuilt. And if it is required, it will say, okay, render object, it needs to be relayouted. So that's why you need to do this, and render object will do the perform layout to actually redraw everything. And how it works with the previous example, you have the column, render object, and everything. You have the text and render object and element as well, and you have the button, same example. And once you see this in the, like, imagine that you push the elevator button, it will call setState to change something in the text. Text will say it needs to rebuild, it will schedule a build again, and it will redraw itself. One thing that you can see here is that there's a special function here, like should repaint, should rebuild. One of the things that we will prove in the next couple of minutes is that in Flutter, if you do not need to change something, it will not do it. It will not touch it. And it will try to keep any resources possible to make your relayouting operations efficient. So, after explaining this, let's take a look at the Flutter's architectural decisions or layers. Like, this is a quite famous diagram. I don't know if you've seen this before. Like, if you have done a bit of Flutter, probably you would be seeing this. The idea is, let's go from bottom to top. Like, you can see there's embedder, engine, and framework. Embedder is actually the layer that is holding all the information about the embedded platform. It can be an Android embedder, iOS embedder. I don't know, you can have your own embedder on a Raspberry Pi, for example. It's totally up to you. On desktop, it is working like that as well. If you go a bit top, now you will see the engine that I talked about earlier, like the graphics engine to take care of the layering and also rasterizing. In addition to this, you will see the isolate and threading happen in the engine layer as well, that is coming from Dart 2. And the part that you will be most of the time be involved is the framework part. It is done with Dart. And you can see that from, again, like bottom to top, you have the foundation to keep all the bases of the information and calculations. Then you will have the animation, painting, and gestures to take care of the like clicking operations and like repainting in each frame and like subscribing yourself to the vsync, which is like frame change operations. And on the upper level, this is gathered as an abstraction for rendering. And lastly, you have your widgets to actually write and to help you to write widgets even better structured. You have material, which is using material design widgets to give you like proper material design alignments, or Cupertino for iOS look and feel widgets. So you can see that this is actually a heavily layered architecture, and only dependency comes from top to the bottom as you would expect. So any part of this is interchangeable. What do we mean by this? The previous architecture was not working for the web, and you can see that for the web, they changed the bottom two layer into one and said, okay, this is called browser, which is going to be taking care of the web outputs, to use Dart to JS compiler or like WebAssembly to create like performant native web applications. So you can see that this plug and play, this like heavily layered architecture is actually really useful if you want to have your own version of Flutter working in any place that you can imagine. And this was on purpose. They wanted to give people a chance to combine any information that they have in their minds to actually gather Flutter as a core system to be run in any place. That's what, for example, right now Toyota is doing. They're using Flutter for their embedded infotainment, I think it's called, like systems in the cars, and basically they write their own embedders right now. You can see that there's a, like, as I said, like heavily layered architecture, but also when you think about the data structures, Flutter uses tree structure a lot. Every structure that you have a connection from is designed to be a tree, and it can have their own address, and they can have a reference to the same level when they need it. And why did I use forest of Flutter? Because Flutter doesn't consist of only three structures. You have, obviously, what I talked about, like widget, element, and render object trees. But at the same time, you have, for example, semantics tree to take care of accessibility for you. You have layering tree, which is taking care of your redrawing operations on the engine layer, and so on, like many, many more. So you can actually see that a lot of operations for you is handled with this tree structure, and when it reaches to a point that it needs to redraw, it will actually take care of only that node and lower from that point. For proving what I have mentioned earlier, we will see and focus on these three structures. So let's talk in detail about these three first, and let's see an example on how it is going to be working. Cool, like we have the widgets. Like widgets are, as I said, they are the contracts, they are the descriptions. Like you can call it even a dummy. It will just hold the information and show it. It will not do anything more, anything less. So when if you work with Flutter, you need to keep in mind that your widgets should be as dumb as possible, because that is what they're supposed to do, and that is how they're designed. The widgets are like, widgets do not have a mutable state by themselves, but they have an object to keep that state in it. And if it is used, what did we call it? Stateful widgets. So stateful widgets will be the ones that is doing the changes. Elements are, as we said, like representations of the widgets. They are the copies of whatever we have. And they just like, they know the information about parent, they know the information about their children, they know the constraints of the parent and the positions of the children as well. So they just help the render object out to draw it out. And that's what render object is doing. It is simply taking care of hit testing, layouting, accessibility, painting, all of these operations that is requiring a connection to the graphics engine. Render object is doing it properly. Render object does not define a child model. Like it doesn't care about the child. It just gets the information and makes it run. That is what it's supposed to do. It doesn't even care if it's on like Cartesian borders. It doesn't care if it's a box which is like already defined, or like it needs to be dynamic. As I said, it just gets the contract and makes the job done. So let's see everything all together now as a real life example. Back in the days, like I've been told that this like infinite list is one of the challenges that they had with like web. I think it required a lot of attention. This is what I've been told. I think like with the Flutter, or like I think it's the same for Android's lazy column as well. Like you have 100 pixels on top and bottom to keep track of the accessibility, but overall everything is recyclable here. And that is why it is performant. But in web, I think it was a hard calculation and it didn't work. Anyway, we will see this simple example and how it works. It is actually like a 10-line of code to do this. So we will see a journey of running an application on Flutter and how it is going to take us to this, changing the state, and how it doesn't change everything on the screen and only changes one thing. So, starting an app. In Java, I think we had like main function to start off our Java applications, and in Dart, it's the same. We have a main function. It doesn't matter if it is a Flutter app or not. If it's Dart, you need to have main function. But when it is actually a Flutter application, you need to run a function called run app, which is going to be expecting a widget, and that widget will be going to the Flutter SDK. By the way, like the code snippets that you will be seeing with this kind of like source, it is from Flutter SDK. And if you don't see it, it's from the example. So in the Flutter SDK, we have a run app function, which is doing like widgets binding initialization, scheduling an attachment to the root widget, and warming up the frame. What do we mean by this? Let's start with scheduling an attachment to the root widget. It will take the widget that we mentioned earlier and pull that into our widget tree. And this widget tree will say that, okay, now I have the widget reference. Let me create an element, and let me create a render tree for this. So I create the two elements in the run app instant, like in the moment that I create the Flutter application. And these two will directly attach themselves into those trees. So we already start our initial nodes here. The next step, what we do is, then we are saying that, okay, let's be sure that we are initializing all the bindings. What do we mean by these bindings? Like, these bindings are actually the way that we communicate with like gesture recognizing, or like listen to the vsync mechanisms, which is a mechanism to actually listen to the frame changes and rescheduling it. Or we can have a services binding like it is here to listen to the platform-specific services. Painting library to trigger when we need to have a painting mechanism. Semantics for accessibility, and many more. But after we initialize this callback mechanism, lastly, we just warm up the frame. What we do is, we have the widget and everything, we have the element trees, render objects. Now we need to draw it. Once we want to draw it on screen, we just start with the begin frame. We tell the begin frame to, okay, like, let's run it, let's like go with the initial drawing, and after it is done, it will take care of the scheduling for the next frame and wait for it to be called by the child widget, the initial child widget. We have seen that we are passing a widget, and like we already talked about how to create a widget, right? Like we had the build function to compose everything together into one widget, which is like, if it is like contained in a selection, it should show a different icon, and there are like tags and like some gestures recognizing events and so on. Let's focus on one of the composed elements here. It's the icon here with the board. And if you create an icon, it's a stateless widget. What did we say about stateless widget? They are just information holders. They just hold the information and show it in a specific way. And if you go to the stateless widget, you can see that it is creating an element inside it, which is called stateless element. And this stateless element is actually a component element to get the widget and either do the drawing for the children, or get the widget and give it a space to have some more children there. And now we can see that we have the element in the tree. One thing that you can also see, that if you don't want to go all the way down to the like source code, you can use a tool from the Flutter ecosystem, like Flutter team, called Flutter Inspector, and you can see the details of the tree, like what it has, and like what are the, for example, for this icon, you can see there are a whole bunch of information, and you can see that there's a render object which is doing the drawing for the font and the icon, because like icons are part of the fonts and they can be drawn as a text. And this is what it is doing for us behind the scenes. And all of these are already defined by the Flutter as an SDK, and all you do is icon something, but what it does is it actually brings back the whole world with you to make it worth it. What about when we update it? Because now we've seen how it is working with the creation. Like we had the set state before, right? And in the set state, we said that there's a mark needs build, like it needs to rebuild itself. And when it needs to rebuild itself, it will add itself to a list for full of like dirty elements to rebuild, and start the scheduling for the next element. When you go and say that, okay, I need to let the render object or the engine know that something needs to change, I need to schedule something, this means that we need to make a stop here. And the reason is that we made a bunch of bindings back in the day, back in the beginning. Why do we need to do all of these operations to reach out to the render object, to the redraw again, but we don't? Because in the widgets layer here, in the previous example, inside the widgets, we have widgets Flutter binding, which we did. And all of these are already happening on the Flutter layer. And we already have a mechanism to listen. So when we actually have a change on the UI and mark the elements as needs to be rebuilt, what we have right now is we are saying that, okay, now we have a change. Now we have something like that is dirty. And what we are expected to do is like submit the changes to the rendering pipeline as layer tree. This is a special tree to keep the information of the changed elements, and they are going directly to the restering part, which is the actual GPU implementation of this. And this graphics pipeline is bringing all the layer tree elements and gathering them together to compose a new UI. And when they are done, they are just going out of the GPU, and it's the same in Android as well. Like you have the vsync mechanism to actually like listen and change the UI components. And Flutter is using more or less the same logic. It is sending a signal called vsync to let all possible subscribers know that something has changed on the UI, and you need to get it animated. If it's animate, we mean that like redraw it, rebuild all the necessary information, then send the message to the render object to be drawn as defined from the GPU. And once it is done, we are settled. So this round trip is actually the one that is helping us to do all of these like drawing operations. So in the initial state, when we had like this empty list of items, you can see, for example, for the item number 8, you have the icon, this icon data 0E25C, and you have the render object with reference 45 AFD. You can take a note of this or try to remember. And we change the reference to it. Sorry, before we go, like on the top we have the infinite list. The state, even the scroll state of it is not going to change. Even the list tiles on the other elements is not going to change as a like render semantic annotation and so on. And once you change the element index 8, you can see that only information that has been changed is this icon data here. All the redrawing operation needs to be done by the render object, and the why am I not looking at here? I don't know. Render object and the like states and everything on the other elements is the same. So what needs to change is only the data information that has been provided to the stateless widget. And all of the heavy workers are still there as heavy loaded objects. So when they are still required, it doesn't matter what you have on the screen. It just tries to find a way to keep all the information. With the previously mentioned, should I rebuild this, should I not, or like how should I proceed kind of operations. And that is what it's doing here as well. It is even keeping this like scroll state of it. So imagine that you're drawing all your elements on the screen, but technically you just change only the pixels that is rendering a bunch of font, like font information. And same goes to the list tile as well. Like all of these informations, all of these render objects that you have here, they are not changed. They are still part of the layouting operations. So far, like what we have learned about like Flutter's history. I don't know, like if you know that it was a web project, if it was using JavaScript before, if you know it or not. The initial name of it was Sky. Like, I don't know if you knew it before. You know how to create a Flutter widget. We've seen the layered architecture of the Flutter. We actually talked about if everything is a widget one. So once someone asks you if everything is a widget, you can say that no. There is like widgets, elements, render objects, semantics, and many more out there. We have seen how the drawing mechanism is working, how the communication with GPU works overall, and how is the round trip happening. And lastly, we have seen the internal structure of Flutter's rendering pipeline. So I left a couple of resources here. If you want to learn more about this stuff, I will share the slides later on Twitter as well. Yeah, thank you very much for listening. That's all from my side. If you have any questions, feel free. Thank you.